Hi everybody, welcome to chapter 7 part 2, where we'll be talking about the type definition, enumeration, two-dimensional arrays, and finally searching and sorting. And let's look at the chapters that we're going to talk about, some of the objectives here. Again, we're going to look at all the type def and two-dimensional arrays, searching and sorting, and common programming errors here, right? So a user-defined data type is defined by using the type def keyword, right? So if you see a type def existing type name, new type name, basically we're trying to change a particular type of a particular data type, right? So in this case we can have type def in integer, type def double decimal, right, which will represent or define a particular data type, right? So here is example of using the type def. We can use the type def double list size, and whenever we use list size, then we're gonna be able to define it as an array with the data type double, right? So this is one of the advantages of using a particular data type here, right? So another enumeration is one type of data type, right? Or it allows us to basically go through a few elements, right? Usually we deal with something that has a few elements, members, right? Or a type of enumerator type, or where we have a lot of numbers, right? So or values. So one of the syntax that we will be dealing with would be enum, the type name, and the bunch of values that we want to define. So let's look at example here. We can use enum, paint type, green, red, blue, brown, white, orange, yellow, right? And this basically, and we can use again this data type and say paint type paint, and we can easily loop through those values that we have defined: green, red, blue, brown, white, orange, and yellow, by just for paint equals to green, paint less than yellow, so it considers this as index from 0 to some index here, and it will loop through. But remember, when we compare this, paint equals to, we have to cast it to the data type that we have defined, right? So be careful with that, right? So, and one thing that we have to be concerned as well is that there cannot be any arithmetic operation on enumeration, like we cannot paint +1 and we'll go to the next element there, right? So be careful with that, right? So there is a couple of examples of using an enum. Make sure you go through it, right? And now we're going to go to a two-dimensional array. Now a two-dimensional array basically consists of both rows and columns. Previously we talked about a single array, right? Now a single dimensional array or one-dimensional array, but a single dimension, two-dimensional arrays would represent the data in such a way that it looks like a table, right? So ideally you can even have three-dimensional array, right? So let's look at how you want to define it. So to declare an array here, we would have to declare an array of the type integer, for example, we would have an integer value and the row and the column that we want to define. So that would be as easy as doing that, right? So let's look at it. If we say value 1 3 here, then we will say that, you know, we can uniquely identify elements in row 1 and 3 columns, right? uh, so so if we say what 3 here, basically we are trying to access row 1 and column number 3, right? So so accessing it, so you have to imagine that you have some kind of a table, right? So, and when you have that table, you can imagine that we are looking at the value that's row number 2 and column number 3, for example, right? Or we can say the first row and the first column, right, would have a specific number of 62, right? So how we deal with accessing it is similar to the single array. You don't really need to use a double array if single array is sufficient, but in some problems you really need a double array, right? So uh, we'll continue again after this slide here, and I'll see you in the next session.